Okay, so the next problem in the lead code we are solving is climbing stairs. Okay, so basically what does it mean here is, let's try to understand the problem first. So we have given the stairs. Okay, like I mean we are here. Okay, we are here and we need to climb the stairs. Okay, and we can simply go one by one, right? That's it, right? Like I mean, but here it has been given a condition that you can either step like one by one. Okay, one step each. Okay, like you can go here, go here, go here, or you can go two step. Either you, like whenever you want to step, right, either you can step one step or you can go to the two step. This is the restriction we have. Okay, so now what has been asked here is we need to find number of ways that is required to reach the top point. Okay, so if you just try to analyze it, right, let's say that if you just walk it normally, we can go to this point first, and then this point first, and this point first. This is one way that I can go to the top. Or what I can do is I will go to this same point, okay, and this point, same point, but instead what I will do is I will go directly from here. This is one more step, correct? Or what else I can do is I can directly jump to the second step, right? If you see it clearly, like how many ways that we took to reach the top, like this is the three ways, correct? I can go one step, or I can go to second step and jump to one. I can just use one step, or I can go to one. I will take one step in the first one, and then I can directly jump to the third. So this is the combination, right? This is the possible combination that we can come up with. So what is this answer here? The answer is 3. Like I mean, number of, what is the number of ways that you can go? That is the 3. Okay, so now try to analyze this problem and how to get the number of like I mean number of paths, right? Number of possible paths that we can go. Like if for a given n, like currently n is equal to 3, we have drawn this solution. This was easy, but now let's check for another example. Okay, okay, so I've drawn the stairs for steps, so is equal to 4. Okay, actually, what we need to make a important note here is, let's say that if I want to go to this 3, okay, like I want to go to the top level. Okay, so like what are the ways that I can go here, right? Like I mean, what are the paths that can come here? So if you clearly watch it, either, and also with the restriction we can go only from this to this one, correct? I can go only from this to this, correct? I can go only this way, or I can go this way, right? Like I mean, as we have a restriction, I cannot jump directly from the stairs, like bottom from to the top. What I can do is either I can go from here to here or here to here. Okay, so now what does it signify is, so let's say that whatever the paths that come to this location will also come to that location, correct? Let's say that I built a some path. Okay, let's say that there is some stair down also. Okay, so I wrote all the combination for this one, and I wrote all the combination for this one. Okay, so ultimately it will be like a sum of these two, correct? Like whatever the combination that has reached this one will reach there. Okay, whatever the combination that has reached this combination will reach there, right? It is like a sum of the combinations that we have done for the second step and the first step. If you want to visualize it here itself, right, let's say that I was able to go to this path. Okay, I, like I mean, n was is equal to 1. Like how many paths did we draw for one? Like we got only one, correct? And how many paths did we draw for the second one? Let's see. Like this is one path and this is one path, right? So how many paths that are reaching to this location? Two curves, that is, one is blue and one is red. That are the combination. I can go to one and go to two, or else I can get directly go to two, right? So now we know the, like how many paths that has been reached to one and two. Okay, so now we are clear here. So now when we come to the step 3, like I want to go to the step 3, it is simply, we can say that whatever the curves that has reached to the previous step, and also the previous steps, we can take a sum of it, correct? So let's say that whatever the curves that has reached 1, obviously will go to the 3. So I can take that whatever, what is the number of curves? Number of curves is 1. Okay, and what is the number of curves that has reached 2? That can also go to number 3, correct? What is the number of curves? I can have went here, red is there and blue is there. So it means that we have got a two paths that we can reach to the point 2, right? If I can take simply sum of this to get the result for this one, the answer will be 3. So meaning, like I mean, whatever the combination that we drawn so far for the step 1, and whatever the combination that we have drawn for the step 2, if we just it's clear that, right? Like I mean, if we are here, we can just jump to this. And also here all the combination that we are done so far, it will also, we can jump to that. So if we take a sum of it, so we'll get a final combination for the step 3. Okay, so what did we analyze here is, so let's say that if you want to draw attention, like I mean, sorry, if you want to draw the sum, right? Draw the sum for, like, I mean, if you want to calculate the what is it, number of combinations for any node, it is simply that the sum of n minus 1, okay, sum of n minus 1 plus n minus 2 combinations. Okay, like if you want to find out a combination for nth node, right, it is always like n minus 1 and n minus 2. Here for 3 we have analyzed it. Okay, it will also applicable for 4 also. Let's say that if I want to do the calculation for this one, it's if we know the value for how many combination comes for 3, right, and 3 and 2, we can simply get the answer for this. Okay, and here with this approach, what we have done is, let's say that we found that only for a 1 we have one combination, correct, and for 2 we have two combination, and with the previously what we have analyzed so far, the previous sum will give us the current combination, so this will be the 3, right? What now, tell me, like, what will be the answer for this? It's a straightforward thing. Like, let's say that I have drawn two combinations to this location, and I have drawn three combinations to this location. Okay, three combinations are there. So now all these arrows can also go to this location. Now all these orange arrows can also go to this location. So it will be like the sum of these two. So what will be the combination that I can get? I can get is 5. So this is what we are going to approach. Like, this is the main theory behind this problem now. So for whatever the node, if you want to find a combination, you will need a dependency of the previous two, like, I mean, this and this. Okay, now let's come to the, like, this is the theory. Okay, like, I mean, if you understood it correctly, like, I mean, how this is worked, so then we can, the next steps are very much easy. Okay, so now, okay, so as per the previous discussions, what we have analyzed is, whatever the, if I want to get a combination for this, I need to get a sum for the previous two, correct? So let's say that if I want to get a sum for this one, I need to get the combination for n is equal to 5 plus n is equal to 4, correct? So what does it signify? So to get the 6, I need 5 and 4, and for to get a 4, I need 2 and 3, and to get a 2, I need 1 and something before that, correct? But there is nothing. So instead, what we can do is, ideally, like, if you look for the solution online, right, it has been confusing actually. Like, they're like, it's kind of counter initiative. What they say is, we need to assume one. Yeah, like, I mean, if you are doing nothing, consider it as one, right? Like, I mean, to avoid all those confusion, that was at least confusing for me. So what I'm doing here is, so let's do the calculation for 1 and 2. Okay, manually we can do it, right? So what is the combination, what is the calculation for this one? Will get, obviously this will be, the number of paths will be 1. This will be, what will be the calculation for this? The calculation will be 2, correct? I can go to 1 and 2 and then to 2, or I can go directly go to the 2. This is the answer we got for 1 and 2. N is equal to 1 and 2. So what we'll do is, if the answer is n is equal to 1, will return 1. If n is equal to 2, will return 2. Okay, that is that. So let me just quickly show the snippet also. Okay, so this is what we are doing. Okay, now let's analyze for the rest of them. Okay, so and what we'll do, like, let's just iterate through this, and n is equal to 3, I can get the values from the previous two values, right? N is equal to, I can take a sum of 1 and 2, and I can get a value for n is equal to 3. And next, I will increment my n, so I can do the calculation for n is equal to 4. How am I going to do? I'm going to for n is equal to 4, what I will do is n3 plus n2, whatever the value that I would have got, right? So I will take the sum here. So basically 1 plus 2, 2 plus 1 will be 3. Okay, when I'm doing the calculation for 4, what I will do, 3 plus 2 will be 5. Okay, and similarly 5 plus 4, the 5 plus 3 will be 8. Okay, and then when I want to get the answer for 6, finally I can do it by taking sum of these. 8 plus 5 is 13. This is the answer for the steps. Like, it means that number of ways, what is the number of ways is 13 number of ways are there to reach the top level. Okay, so this is the all the theory things. Now let's quickly check the code. If you understood this so far, like, it's a straightforward thing. Okay, so as we saw, if it is n is equal to 1, will return 1. N is equal to 2, to return 2. Like, this is our, like, kind of either you can set our base condition as 1 actually. Okay, let's not go there. Okay, so n is equal to 1, will return 1. If it is n is equal to 2, will return 2. Let's use these two to build the n is equal to 3, 4, 5, 6, whatever the value that is asked so far. So ultimately, what was the final value we get, right, in the upper step, that will return it. So that will be our answer. Like, I mean, if we are asked to here, as we just discussed, n is equal to 6 was asked, so we used the predefined calculations to build the n is equal to 6 value. That's it. Yeah. Thanks. Let me just show the code once again. Yeah, that's it. Thanks. Okay, so as we discussed the other problem, right? Let me just quickly discuss the other problem also. Like it's a kind of same thing, but small things are tweaked here. Okay, so what is it being told here is here also we'll be climbing the stairs, and it is have the same restriction that either we can go, either we can jump to one step or two steps. Okay, either we can jump one step or two step. What does it mean here is, let's say that what they are asking is like now we'll have to pay. Like it seems like if you want to climb, right, they have attached some pair to fare to this, we'll have to pay for it. Okay, like let's say that if you want to go for this one, you will have to pay 10 rupees. Like if you want to go for this one, you'll have to go pay for 15 rupees. Okay, and ultimately we'll have to find a path that will cost us the minimum, like I mean, minimum price that will cost us. Okay, so let's do the same analysis here. So let's say that we did some combination. Okay, like we'll have to try all those combinations, and we'll get some different prices. Correct, let's say that if a 100 rupees is there, I will have to pay for this and all this combination. Okay, so ultimately I have drawn like I mean there is some combination ultimately. Okay, so here we reached the step 6 with the 150 rupees and step 5 with 125 rupees. Okay, now let's try to analyze, like I mean, what is the common pattern that we can draw from here, right? So if you want to go to 200, which one will you choose, right? Like I mean, currently the fifth path is 125. Actually you can simply analyze it like this way. Okay, like for now let's forget this because I've already drawn it, so I'm trying to fit my requirement there. So let's assume that you don't have anything here. Okay, so now here you are at the top level 200. Okay, and you are at 150 and 125 rupees. So what is the minimum cost that will take you to go to 200? Correct, like I mean, when you are at this precision, you will get only two possible ways, right? I cannot jump from here to here as we discussed so far. I can go only from here to here or here to here. Correct, I can go, there's only two way. So that's why I'm considering only these two solution. There can be like here, this can be like 100 or whatever it is, but we are interested only in the last two values. Okay, so now the person, either it can be he can be in here or here, which one will cost him the less value. So however he will have to pay 200 rupees when he goes to these steps, like which one will cost us the less amount. That's what we need to think. So if I take this path, right, let's say that there was one path that constitute to this one constituting 150 rupees. So 150 plus 200, right, that will be one amount. And or else there is one more path that is constituting to me to the fifth level, fifth staircase, that has led to 125 rupees. Okay, and I can simply jump to the second step. Okay, that will be costing me to the 200 again. So what it will be, 200 plus 100, 325 or something, this will cost to 325. And it will be around how much it will be, 200, 300, 350, it will cost me 350, and this will cost me 325. So we can analyze that this is the best path for us. Correct, like I mean, there can be multiple combinations that lead to this path, and we can simply choose this one instead of this. Okay, so what is the analogy that we can draw here is whatever the minimum value out of this one. Correct, let's say that this is 125, right? Whatever the minimum value between the n minus 1 and n minus 2, okay, that is 125 is the minimum, and we will have to pay the current value. So that is the formula that we need to draw here. Basically, minimum of n minus 1 and n minus 2, which will cost us the less value. Okay, and into the whatever, sorry, not into, plus whatever the new fare that we are going to pay, the current cost. Okay, this is what will give us the solution, like I mean, to identify the minimum pass. Okay, so now let just quickly look at the answer. So what let's do is, similarly as this problem climbing stairs, we'll say that if the length is equal to 1, right, we'll just return whatever that is being given there. Okay, whatever that is given in the first thing. Okay, 1 second. Sorry, this will be not valid. I remember seeing the constraint as 2 at least. Okay, yeah, we don't need this at all actually. So let's just comment this out. Okay, and so we'll be having only stairs from 2 level 2. Okay, so level 2 can be 1 comma 100. Okay, 1 comma 100, we can just simply take minimum of either of these. Correct, minimum of 1 or 2, because what I can do is I can go to 1 and I can jump it directly, right? So or else if it was like this, right, 100 comma 1, I can jump directly to the second step. Okay, and I can go, like I mean, I can minimum of these two value will be the answer when length is equal to 2. Okay, so now let's do one thing. Let's set our value. We know that what is the value for n is equal to 1 and n is equal to 2. Correct, we'll set that as n and n2. Okay, now from the step 3, we'll do the analysis based on what we calculated so far. So what would we draw the analogy, like it should be minimum value, like whatever the, we know that we can go only two ways to this path. So we'll see like which one will cost us less. So this constitutes some 100 rupees and 125 rupees. Now sorry, this one 150 and 125 rupees, we know that this is the best path, so we'll update that as the shortest shortest path that we can reach, right? Okay, so this is what is happening here. Okay, minimum of lower step and upper step, and add the cost, current cost to it, and now we'll have the latest value for the current step. So ultimately when we reach the end, right, so we'll have to make sure that there is a condition when it is even and odd, or simply what I can say is, okay, let me, what I was explaining was, okay, ultimately at the end, right, it can be like this. Okay, so this is the steps we got. Okay, and if you want to calculate the final value, what I will have to do, I will have to find the minimum value out of this 5 and 104. Correct. Well, 5 will be the answer, 5 plus 6 will be the answer, will be 11. Correct, minimum value. If you draw the, if you follow the same formula, right, this will be the 11. And similarly when I take 6, minimum value is 4, 4 plus 6 is 4 plus 6 is 10. Correct. So now what is happening here is, so we are telling that 10 will be the my answer. Okay, but what will happen here is, let's say that if I am already here at this location, I can simply jump out of this, right? I can simply jump out of this. I can, why do I need to pay for this one? Correct. So that's why what we'll have to do is, we'll have to make sure that minimum of these two, like if you, whatever the calculation we done for so far, right, 4 comma 10, if I am coming from here, I will have to be paying one more 6 more rupees, and it will constitute me for 10 rupees. Okay, and if I'm already here, if I choose this path and I'm already having the I paid only 4 rupees, I can directly jump out of it. Correct, I don't have to pay 6 rupees here. So that's why what we'll have to do is, after doing our calculation, we'll have to return the minimum value of the lower step on the upper step, that is as shown here. Yeah, okay, that is it actually. So you can just read this code for if you understand that base condition, right, then we are good here. It's like once we understood that formula for both of this, it will be easy to understand, and you can just read this code, so it will be clear. That's it. Thanks.